I want to make money in Stardew Valley, and one great way to make buckets of cash is by grabbing your trusty rod and going fishing. But as with most programmers, I'm lazy and highly allergic to repetitive tasks. That's why today we're going to create an AI to do the hard work for us. So let's explore the problem. The fishing minigame has a simple concept, but it can be tricky in practice. The aim of the game is to keep the green bar behind the moving fish until the progress bar to the right completely fills up. First things first, let's just try writing a program to press the C key. We're going to start by importing pynput and make it press and release the C key repeatedly. That's definitely working. Perfect. Now, I've never tried image location before, but after some research, I'm going to try using PyAutoGUI, which can, when you give it a target image, it can find it on screen. This sort of works, but the game has to be in windowed mode, and I had to use PyAutoGUI's screenshot function to get the exact image without any compression. It was also really slow, taking a second or two to find the image each time, but it did work. I created template images for the top of the fishing UI and the fish icon. As the fish is always on top of the green bar, it's always visible and can always be found, but that means using a template image of the whole green bar isn't possible, as the fish being on top of it changes the image. Instead, I just made a template of the top of the bar, which has less chance of being covered. Now we've got input to the game with the keyboard and output from the game using the image locations, we can try to keep the bar under the fish. Ideally, we want to keep the fish in the middle of the bar, so that's where we should define the distance from, or the error as we'll call it. I worked out the center of the bar is 76 pixels down from the top of the bar, and since the number of pixels is measured from the top of the screen, the center of the bar is the vertical location of the top of the bar plus 76 pixels. Taking the position of the fish away from this results in the error between the bar and the fish, with a positive number if the fish is higher than the bar. So let's just slap an if statement in there, and if the C key is positive, we'll press the key, and if it's negative, we'll release it. Simple, right? This didn't work at all. There were so many issues. The biggest problem was how slow the image finding was, because by the time it found where the bar and the fish were, the program had already held the C key for way too long, or not at all. It also couldn't find the bar if it wasn't under the fish, because the bar starts flashing and then the template can't be found. Another issue was the momentum of the bar. As the key's held down, the bar builds upwards momentum, and by the time it reaches the correct position and the key's released, it often has too much momentum which carries it way past where it should be. I tried restricting the search region of the images, using a narrow area to find the fishing UI, and then using that position to narrow the search even further for the fish and the bar. By doing this and using grayscale images, it did improve the speed, but it still wasn't enough. At this point, I was feeling kind of demotivated, as this project had seemed so simple when I started it. But then I remembered something. OpenCV. I'd actually used this before in conjunction with MSS, following a tutorial by Centdex. Starting a new program, I added the code, and it was getting the game frames at around 60 FPS. Good start, but how do I find images with OpenCV? A quick Google and clicking on the first Stack Overflow link gave me the answer. The template images are first imported as grayscale, then moved over the grayscale screen image to find a match. There's even a threshold value for how confident the match is, meaning the bar can still be found even when it's flashing. Perfect. The program's finding the images at around 12 FPS, an incredible 12 times as fast as using PyAutoGUI. That's definitely solved our speed problem. Unfortunately, this isn't the only issue with the program, as we still need to cope with the bar's momentum. Instead of holding down the key when the bar's below the fish, and releasing it when it's above, why don't we hold the key down for different times depending on how far away from the fish the bar is? That way, as the bar gets closer to the fish, the key's held for less time and the momentum's lower. This is where simplified PID Control comes in. PID stands for Proportional Integral Derivative, but we'll just be using the proportional part. The formula is simple, y equals k times x, where y is the input to the system and x is the output from the system, and k is a value of our choosing. Within the context for this project, x is the error and y is how long the key's held for. This should be working in theory, but I've encountered yet another problem. When the key is being held, it prevents the program from running further until the key is released due to the time.sleep function. This means the longer the key is held, the less frequently the error is updated. Thankfully, this is a simple fix, as although I haven't used threading in Python before, it was simple to look it up and copy a couple of lines of code into the program. Now when the key is being held, it does so in a separate thread and the rest of the program can keep running. Much better. After tweaking the value of K, this actually seems to be working. Simple proportional control works fairly well, but we could definitely do better. Firstly, imagine the fish is a little way above the bar. What would you have to do? You've got to hold the key down, right? But what if the bar's already moving very fast? You'd probably be better off not pressing the key. Conversely, if the bar's moving downwards quickly towards the fish, the key should be held longer to slow the bar down. This suggests including the change in error between frames could probably improve control of the bar. Secondly, imagine the bar and the fish are moving quickly in the same direction. If the fish suddenly changes direction, the bar will likely overshoot as it's moving too fast. So we can include the change in bar position between frames to increase or decrease hold time if the bar's moving too quickly. So the two output values added to our equation are the change in error from the last frame and the change in the bar's position, aka the error velocity and the bar velocity. This makes our equation W equals A times X plus B times Y plus C times Z, where W is the hold time, X is the error, Y is the error velocity, Z is the bar velocity, and A, B, and C are all control parameters. After playing around with the parameters to a point I'm happy with them, we can finally put the program to the test. Let's do this. So I did a full day of fishing and hooked a total of 22 fish, all of which were caught by the program, and 13 of them were perfect catches, which is a huge improvement and a more than satisfying performance. To test the program further, I've decided it would be good to start from a new character. Turns out we've got another problem. The green bar can be different lengths and is much shorter when you're just starting out. Time for the final test. Starting from a new character, I hooked 21 fish, 4 of which were perfect catches, 14 normal catches, and 3 missed. Obviously this program isn't perfect and would definitely struggle with some of the more difficult fish, but getting it to perfectly catch every fish in the game would require way more time than I have available. I'd love to hear your suggestions on how to improve this, and I really encourage you to give it a go yourself. Hopefully you found this interesting, and I'll catch you next time. See ya!